Hi, Spring fans! In today's installment of Spring Tips, we're going to take a look at some alternatives to low-level SQL when you're doing data access with a SQL-based database or RDBMS. We'll start today with MyBatis. Now, for those of you who've been in the Java industry for more than 10 years, you'll know that MyBatis was at one point a project called iBatis, and iBatis was started by Clinton Biggin. Gosh, it's got to be at least 10, 15 years now. I mean, 2001, 2002, I'm not even sure, but it came up in the early days around the same time as Hibernate and Spring, so I remember it fondly. At the time, there was very few sort of good open options for persistence, for SQL mapping, right? For object relational mapping. I remember at the time there's also uh, Apache OJB, for example, right? So there's been a lot of options that have come and gone, but iBatis, now named MyBatis at Apache, has gone the distance. It's survived as long as Spring has, and more, and so that makes it certainly a choice worth looking into. One thing that's been very interesting to me in my travels when I talk to Spring community members and users all around the world is that while I don't hear much about MyBatis here in the West, it is extraordinarily popular in China. Very, very popular. In fact, some of the largest websites on the planet are using MyBatis at scale. So that says volumes, right? It's still got a very large active user base there. It's still being evolved. It's still very much in demand. So it makes me think we should revisit it. And so I think it's a good choice for today's Spring tip. So what we're going to do is we're going to build a Spring application here. We're just going to call this MyBatis demo. And we'll use the auto configuration for MyBatis. Now, this integration is not developed by the Spring Boot team proper. It's actually been developed by the MyBatis team. And I'm happy to share that I also contributed to this auto configuration, this support on the MyBatis project after seeing the demand for it, the demand for MyBatis integration with Spring Boot. There are other people that actively contribute to this, and it's maintained by the MyBatis team. So it's really it's always evolving, it's always growing, and that team makes sure that the Spring Boot auto configuration is the best in breed sort of support possible. So we're going to use MyBatis. We can use H2, which is an in-memory embedded SQL database, because it'll make it much easier for us to prototype something. And we're going to use Lombok because I don't want to spend too much time building up the object that we're going to persist into the underlying data store. So I'll build a DTO, a POJO, right? Something that'll get mapped to our underlying data store, and then that should do. So we'll go ahead and hit generate, and open this up in our IDE. Okay, so what we have here is a new application. It's a Spring Boot application. We're going to, as I typically do, I'm going to contrive a simple example so that we have something with which to work. So we'll create an entity of type car, and we'll give it a few fields here. It's going to be a Lombok data class. So Lombok, as a little bit of background, is a Java preprocessor, so to speak. It's a Java agent that'll, during the compilation, it'll add things based on these compile time annotations. In this case, if I create a field here called make model, we'll get automatically getters and setters for those fields. I'll add a setter and a field rather for year, and of course we need a field here for the ID. Right, so we're going to persist all that. If I want to, work with this, I would need to create an instance and then set the fields by calling the setter. So I'll have a Lombok generate an all argument constructor and a no argument constructor, so I can easily create them without explicitly calling setters. I can just do constructor-based construction. And now what I need to do is I need to be able to save and work with instances of this data. So, I'll set up a command line runner, which is a Spring Boot interface that, when seen, will be activated on startup. And I will want to insert some data in the database here, and I want to do that using MyBatis. Now, the central concept with MyBatis is this idea of a SQL mapper. It's a thing that tells MyBatis how to take method invocations and turn them into executions of a given SQL query, right? So with MyBatis, the SQL that you're using is very much front and center. So this is a nice choice if you want full control of the underlying SQL, the underlying sort of persistence queries and so on, all the queries that are being used in the underlying data store. And I think that's a good idea. If you're building an application using a data store, the last thing you want to do is try and treat it like a dumb CRUD bucket where you create, read, update, and delete entities by their ID and completely ignore the real power of that data store, which is the analytics capability. So there's a couple of different ways we can give MyBatis that mapper. The first, and I think the most sort of approachable way, is just to create a declarative interface here. So I'm going to create a car mapper, and I'll annotate it with the iBatis, MyBatis now, mapper annotation here. And I'm going to create a few methods here. So I guess we need a select method. We need a method to find all the records by ID. So let's say collection select all, and we can annotate this. We can annotate this with an annotation to signal to MyBatis what the query that we want to use is. So select all from car, and that will work, right? The results from this query, when we create it, we're going to make sure that the results from the query give us a value called make, model, and an ID, and MyBatis will convert that result set back into a POJO for us, because it'll infer the type of POJO from the return value here, and it'll bundle it up into a collection, and that's it. Right? So I guess we need a table first. We'll go here and create a new schema.sql, and again, a schema.sql is a Spring Framework JDBC mechanism, right? It'll be evaluated when the application starts up. You can also put a data.sql. You can also put a data.sql that'll get evaluated after the schema.sql has been evaluated. So you can describe your schema, your DDL here. Here we're going to say that we want to use H2. We'll say drop table if exists car. Then we'll say create table car, and we're going to have a couple fields. We said we're going to have an ID serial, not null. It'll be a big integer. Then we're going to create a field here for the make, so that's a var car, not null as well. And another one for the model, that's another var car, a string, so we'll say that, not null. And another one for the year, big int, whatever, 4, not null. And format like that. Okay, big int, I suppose that would be fine. In fact, we'll just do int. There we are. So that'll be the year. That'll be our little table. This is a primary key. We don't have to worry about that too much, but we'll see that. We'll see how we have to care about that when we insert records. Right? So there's that. So this will be a select. We need to be able to insert records, right? That's the next thing that's going to be important. So let's, for now, see where we're trying to go with this. Let's look at the destination by actually getting to the finish line here. We're going to say select all, and visit every single record that comes back, and confirm everything works. But of course, in order for that to work, we need to have some data in the database in the first place, which gets us to needing a insert method. So we'll create an insert here. We'll say insert into car, make, model, year, values, make, model, year. So what we're doing here is we're writing a SQL statement, and we're using a special syntax here. You notice that we're using a special syntax in the SQL statement. This is this is an expression that's, I think, going through OGNL, which is the Object Graph Navigation Notation Language. That is also pretty old technology. If some of you may remember, it's used in things like WebWork and Tapestry, for example. It's been around forever, so it's a very, very venerable query or expression language. But the point is, we're evaluating here a field that's set against a context. So this will correspond to the car and the car.model, car.make, car.year that we pass into the parameter, of the insert method here. So there's that. Now we want to be able to make sure that when this car is inserted, that this return value, this object, has its newly established auto-incrementing key set on the object itself, so that we can interrogate what the just inserted object's ID is. So we need to specify an option. We'll say options, and we can see that it says user-generated keys equals false by default. We're going to say true, and that should give us enough to see things in action. So let's say arrays.asList, new car, Honda. What are the fields here? We've got a Honda Civic 1984, no primary key. Okay, and another one of these. We want a BMW 330i 2012, and perhaps we'll have a Infinity Q50 2014 or 15. Yeah, there's that. So there's a few cars here, and store them in a variable. And I'm going to visit every single record in that array list here, and we're going to just insert it using our car mapper. So car mapper insert, and if everything goes to plan, I should be able to then drag every single record back out of the database and print them out here. And we should see that these objects now have IDs assigned to them, even though they were null here. Right? So actually, we can take that a step further. We can say for each car here, car mapper dot insert car, and then car.toString. So now we'll be able to see, before we even do the select all, we'll be able to see the 3 records on the console with their IDs. Then we'll see all 3 at the same time. And just to partition things off, I'll make it a little bit more explicit that we've got one thing happening after the other. So I think that's enough to get started. Let's go ahead and give that a whirl. All right, so there we go. There's our 3 records that we inserted here. There's the 3 cars with their auto-incrementing serial IDs that had been assigned. So it's sort of like an out parameter. We put the parameter in, and on the other side of that execution, we have the parameter available, the ID is available, and here we can confirm that that is actually persisted and so on automatically for us by doing a select all. Now, we can do, there's a lot of other things we could do here. We could create a method to delete. We could say delete by ID, long ID, or even just wrong ID in this case. So delete from car where ID equals ID, and that would give us what we expect. We can do an insert, but what I really want to do is I want to do a search, a dynamic search method. I can search for all the cars that have either a make, or a model, or a year, or all 3 of them, any combination of those 3 parameters. So I'm going to create a search method, but it's not easy to do this dynamically. What I want to do is I want to dynamically create the query if these things are not null, or if they're not 0 in the case of the year. But if they're not there, I don't want them to be contributed to this query. And of course, these queries are in the annotations themselves, which means that I can't do any kind of if-then conditional logic in this annotation. So another way by which you can describe a mapper to MyBatis is to use an XML file, right? And this is actually the mechanism that predates this sort of annotation-centric approach, because MyBatis itself predates annotations, very much like Spring predates annotations, right? So what we're going to do is we're going to create a mapper XML. I'm going to copy an existing file here, which has the basic skeleton of a mapper to our example here. So we'll say source main resources, and put that here. I need to create a new directory now, com example, and we'll move carmapper.xml to com.example. Open this up, and we've got a sort of a stock standard basic empty MyBatis schema here. I need to tell it the namespace for this particular mapper. I need to give it basically the class itself, right? So this used to be optional. Now it's, I think, all but required. I think it might even be required. I don't even know. I just know it's a good idea. And then here we're going to provide a select query for the search method, right? And the select query will be, as you expect, select all from car. But then we want to provide a where clause where some things may dynamically be contributed. So we're going to say where if test if ID does not equal 0 and ID does not equal null, ID equals ID. Right, so we're going to contribute this string if this test is true. If test make does not equal null and make equals make. Now, one thing you may be wondering is what happens if, for example, this isn't present? MyBatis is smart enough to go through and remove that extraneous sort of superfluous and in this case. So it'll evaluate to select all from car where make equals whatever you pass in, for example. So it'll automatically remove the prefixed and for us, making it easier to do the right thing and still look at the query in your head and understand what's happening. We're going to create another test here. So we're going to say model does not equal null. And we'll say and model should equal model. One thing you may have noticed is that up here, I used and, right? This is very useful because we're in an XML document, and this causes sort of parsing error. So we're just going to use and like this. And I think that'll do. So if we do everything correctly, then the default behavior, if you specify no parameters, or a parameter with a 0 for the ID, is to just select everything from the database. But we can qualify or predicate our search by specifying any one of the 3 parameters. So let's go ahead and try that in action here. Okay, so we'll go back to our code block here, create a new partition, and we'll say car mapper dot search, and we're going to specify the that we want the Honda and nothing else. So we're not going to specify the model or the year. And if everything goes to plan, we should get one result back, like so. Now, this interface has method parameters here, and these parameters are not obvious. They're not visible to the to runtime reflection, right? If you have a Java class in Java 8 or later, the debug information, or rather the metadata about those parameters is now baked into the reflection hierarchy for concrete classes. In previous versions of Java, you could use debug information to get the information about what the name of these parameters are. But even as of Java 8, there is no way through reflection to ascertain the name of these parameters, so you need to annotate them, right? If you ever use Spring Data JPA or anything in Spring Data, you'll notice that we have the same thing when you're trying to export a repository, Spring Data repository, to a REST API. You need to tell the framework the name of the parameter. So make is going to be named make, model will be named model, and year will be named year. Okay. So let's see what we got. So that's one search by Honda. And we have something wrong here. Search car mapper is in the resources. Oh, ID. We don't care about the ID. We care about the make, the model, and the year, not the ID. That was my fault. Okay. Aha! So it's now complaining that it doesn't know how to take the data that comes back from this and give it to us in something that we can use. So we need to say that the result type is a com.example.car, which is obvious to MyBatis with no signature with the annotation. But remember, we're not triggering or activating this particular mapping through an annotation. We're using the XML, so we need to be a little bit more redundant, a little bit more explicit. And that done, we get a result. So everything is working as we expect with that. Let's try switching it up. Let's see what happens if the first two parameters, the first parameter and the last parameter is null. So we'll go to our command runner, copy this bit here. We'll say null. We'll say we want the 330i, and the year is 0. We should still see one record. This is the Civic, so let's rerun it. Alright, that seems to be working fine. Good. Now let's try all 3 of them. Let's just send nulls for everything. So null, null, and 0. Right? So tantamount to null. We should see all 3 records, registered on the console. They're recorded on the console. And there we go. Honda, BMW, Infiniti, all three of them. So that works. So we've looked at how to build a very, very simple SQL mapper using MyBatis. This is a technology that stood the test of time. It's being used at some of the largest websites on the planet. I guarantee you, on huge websites that are that serve billions of people in China. It's a very, very powerful tool, and I encourage you to take a look at it. And if you want something lightweight and fast and approachable and fine-tunable, and still, I think, very elegant, right? It's hard to argue at the elegance of this mapper. It's a little bit more robust, a little bit more tedious, maybe, than just a convention-centric Spring Data repository interface, but it's very much the same thing, right? Except that here you're forced to provide the query, which is fine. It's not all that bad, right? And you can do other kinds of tests. It's worth noticing. It's worth noting that MyBatis supports providing the same query in the XML using conditions. You can say, okay, if the database right now is H2, provide this query. But if it's Postgres or MySQL or something like that, then use a different query, right? So you can do a lot of really interesting things here to keep your SQL away from the code and to make it as conditional and dynamic as possible without having to resort to kludgy strings and if tests and plus signs all over your Java code. One thing we didn't get to look at in this Spring tip is the natural next steps now that we've got basic data access functionality working with MyBatis. Suppose we wanted to load a object graph which features a one-to-many relationship with a master object and then multiple sort of dependent objects. You can do this very easily with MyBatis, right? It's a function of MyBatis to support loading a master record and then providing the query to load the dependent object on the other side of the relationship. And you can specify that both in the annotations or as part of the XML. We also didn't get to look at the right place to put this data access technology in a complex application. Any kind of tedious data access functionality should be in a repository object. And of course, in the Spring framework, that models itself very naturally as a @repository component. If you have functionality that is meant to be atomic, maybe you want to do multiple things inside of a single atomic body of work or batch of work, you can decorate your methods with @transactional, right? The Spring framework @transactional. And you can see the Spring tip on JTA for a little bit more on this, and there's numerous other resources on that as well. So consider that while we've done just a cursory look at what can be done with MyBatis, this kind of functionality, the data access functionality, should live in a repository object. All right, with that, thanks for watching, and we'll see you around next time.